Hi there, everyone. Welcome to our webinar today. We're excited to get started, and we'll do so over the next couple of minutes. But first, we have a couple of housekeeping items to remind you of. Today's webinar is being recorded, and over the next couple of days, we'll send a follow-up email with the links to the slide deck as well as the YouTube recording. If you're interested in receiving that content earlier, feel free to follow us on YouTube and on SlideShare. I will send out the link to both of those channels in the chat window. Additionally, you'll note that there's a Q&A pod that's ready for any questions that you have at any time. We have moderators standing by who will be able to engage with you and answer any questions you have, so feel free to send those over at any time during the presentation. Without further ado, today's webinar is titled Serverless Analytics with Amazon Redshift Spectrum, AWS Glue, and Amazon QuickSight. Our presenter today is Ben Snively. Without further ado, thanks, Ben. Looking forward to your webinar.
Hello, thank you for joining us. We're going to be covering serverless analytics with Redshift Spectrum, AWS Glue, and Amazon QuickSight. My name is Ben Snively. I'm a specialist solutions architect in data and analytics, and thank you for joining us. In today's session, we're going to be covering some key aspects. The first is, what is serverless, and how can serverless really help you in your data warehousing and your big data workloads? In that, we'll talk a little bit about enterprise data warehousing on AWS and Amazon Redshift specifically, and then show you how you could complement your data warehouse using Redshift Spectrum by being able to query your data on S3 and join it with data sets that you already have within Amazon Redshift. From there, we'll dive into data cataloging and how you could leverage the AWS Glue data catalog to be able to categorize both your data in your data lake as well as your data warehouse. We'll talk a little bit about how to go into serverless ETL and populate your data warehouse, and then demonstrate how you could drive insights using Amazon QuickSight, Amazon's serverless business intelligence tool. And then we'll really bundle this all together or show you guys how you could do this through a demonstration, and then a few wrap-up points. So what is serverless? When we're talking about serverless, we're talking about an architectural approach. When AWS started in 2006, customers were really excited that they could launch things like EC2, our virtualized servers. And that was really, really powerful. You could easily provision servers, you could focus on the OS and above, and very easily elastically scale servers. Over time, what we've done through customer feedback is we really heard our customers asking for more managed services. So with managed services, you still think about servers, but AWS will handle the heavy lifting of provisioning the cluster, making the cluster highly available, and really operating the cluster so you could focus on writing more of your analytics. But with managed services, you still thought about servers. For example, Redshift is a very, very powerful data warehouse. It's fully managed on AWS. But you as a customer still think about, how big of a data warehouse do I want? With serverless, it's a different approach. So it really allows you to build applications and services without thinking about servers at all. You don't have to concern yourself with the provisioning, the scaling, and the maintenance of these servers. AWS does all that for you, so you could really focus on the analytics, focus on the ETL, focus on driving insights for your business. And some of the core tenets of serverless is really being able to not have to worry about managing these servers. There's no servers to provision, there's no servers to manage and make highly available. And fault tolerance is built in. The other aspect is it scales per usage, and we'll demonstrate this throughout today's session. As we query massive data sets on S3 through Redshift Spectrum, as we're performing ETL using serverless ETL within Glue. All of those are per usage, so as I'm executing, it's only billing me based on the execution time. And that really drives the never pay for idle aspect of your resources. So as we're going through this session, we're really starting with your enterprise data warehouse. Amazon Redshift is a very powerful enterprise data warehouse built on the cloud, and it really allows you to store petabyte scale data warehousing. It allows you to scale up to that, so you could start with a few hundred gigs and easily scale up to multiple petabytes, and has a lot of the heavy lifting of running the data warehouse for you. So you could very easily plug in your favorite BI tools, you could use your various data integration partners, as well as use things like Glue and QuickSight, which we'll show you today. And the service is really built across three tenets. It's built on being very, very fast. It's built to be a data warehouse, OLAP type transactions or activities. It's very simple to use. With a few simple knobs, you can make it very, very performant and very fast to use. And it's inexpensive, very, very cost effective compared to other data warehousing. These are some of the customers that we like to talk about when we're talking about Redshift customers on AWS. And we've really seen across all of our industries a rapid growth of data warehousing on AWS, ranging from financial markets such as Nasdaq and FINRA, educational institutes like Ivy Tech and UMUC, healthcare organizations, many organizations that are picking up Redshift and using them. Here's three examples. Looking at Salesforce, for example, Yelp and Nasdaq, three very key customers that are doing very heavy Redshift workloads today. Redshift came out, a couple years ago, and what you can see here is really the pace of innovation on Redshift. There's been over 140 new features since it's launched. And the nice thing about this is, as you're running your Redshift cluster, your data warehouse, automatic patching happens. So it's a fully managed service. You don't have to worry about patching the data warehouse, and we push out these various changes out to your cluster. One of the most recent changes, which really falls this under the serverless category, that we're really excited about, is Redshift Spectrum. What Redshift Spectrum allows you to do is have your hot data or have certain data sets stored on your data warehouse. Those data sets could be stored on the instance storage and very, very performant for all your BI users. Then what you could do is you could have different data sets that are stored out on S3. And what it allows you to do is query that data set as it lives on S3 without having to load the data into the cluster. You might do this because you have hot and cold data sets. You might have other scenarios, such as you're bringing a new data set into your data warehouse and you want to do some queries to understand what that data looks like, joined with your data that's already in your cluster. It's very, very elastic and highly available, and it's pay per query. So you don't have to pay anything when you define your external schema within Redshift Spectrum, besides the storage costs of what that is at rest on S3. And then it's really $5 per terabyte scanned as you're querying that data. The nice thing about that is, if you're bringing a new data set into your data warehouse, it's very easy to keep the data in its raw form. So let's say you're bringing in a completely new data set that's JSON, CSV, Parquet, various formats that you might be bringing in. You could bring that data into S3. You could define your data schema through a data catalog. We'll show you how you can use Glue to do that, and then easily query that data set within there. And the powerful aspect of this is you can very easily join that across your other data set in your data warehouse and have the full SQL support of Redshift. So from your user's perspective, they could issue the same sort of queries that are issued through the Redshift JDBC or ODBC front end. This is an architecture diagram of how it works. So what happens is when you're launching your Redshift cluster, you launch it with a certain number of compute nodes. There's a leader node that's launched automatically that all of the different clients and BI tools interact with through either JDBC or ODBC. And that's kind of the core Redshift cluster. When leveraging Redshift Spectrum, what happens is when it's issuing the queries against your data in S3, it's issuing those queries to a set of Spectrum nodes. And these nodes are very, very optimized to be able to bring the data back to your Redshift cluster and join it with different data sets. It leverages things like pushing the predicates all the way down when possible to be able to limit the amount of data returned. Things like group bys could be done at the lowest level nodes before bringing the data back up. And various optimizations to be able to really optimally query your data as it lives on S3. You don't have to provision any of these Spectrum nodes, so all the nodes you see in green are automatically handled by AWS. That's what makes it serverless. So you don't have to worry about how many nodes it takes to issue your query. Your compute nodes really just issue the queries out to the Spectrum nodes and return the results. This is really where we also start showing where it's integrated with the AWS Glue data catalog. The AWS Glue data catalog, which we'll talk about shortly, allows you to define various data sets, both in your data lake in S3 or your object in S3, as well as things like Redshift, and various data sources like that. So the AWS Glue data catalog allows you to define your data in S3 and be able to really have your data addressable so that things like the Spectrum nodes could query that. So next what we're going to do is we're going to look at the life of a query, of what it looks like when a query comes in and you're querying your data on S3 through Redshift Spectrum. The query comes in through the BI tools or through JDBC or ODBC as if any other query would through your Redshift cluster. What happens from there is the leader node really looks at the query and optimizes it in order to identify what should be run locally on the Redshift Spectrum nodes and what really needs to be brought up to the various compute nodes within your cluster. The query plan gets sent to all the compute nodes, and from there, the compute nodes actually talks to the data catalog. This is done dynamically, and things like dynamic prune partitioning happens at this level. So if your data is partitioned within the Glue data catalog by year or by date, and you're specifying a date filter, it will automatically make it so that only those dates within that query will be scanned against or queried against. Each of the compute nodes then issues multiple requests to the Redshift Spectrum layer, and from there, the Redshift Spectrum data actually scans your data in S3. Very, very optimized to be able to do this. There's various best practices you could take, such as storing your data in column-oriented, such as Parquet, which will really speed up these queries as well. From there, the Redshift Spectrum will actually project the various filters, aggregations at the node level there. And then what happens is the aggregations are sent back to the compute nodes. Once the compute nodes has all of those aggregations, it's able to really finalize the results and send it back to the client. So throughout this flow, what you'll see is essentially the query from the client is still coming in through a BI tool, JDBC or ODBC, and really stepping through the entire flow in order to make it so that it could query your data as it sits on S3 and then spin it back up without having some really complex things done at the client level. The client can really just query their data set and join across these various data sets, both on the compute nodes as well as your nodes on your Redshift Spectrum. So that was a little bit about the Spectrum flow. How are we gluing these things together? We have a service that we recently went GA at the New York Summit called AWS Glue. And it really plays a key part of this. The first part is being able to discover your data sets. In the flow that we just went over, there is the data catalog. The AWS Redshift Spectrum is able to talk to the AWS Glue data catalog to be able to know what data exists, what form to query it against, and be able to query that data. AWS Glue also allows you to create ETLs through a serverless ETL engine. It's very easy to create your own ETLs using a wizard or provide your own PySpark code to write your ETL. And this really goes into three main components. So there's the Glue data catalog, which we're going to demo, which allows you to have a Hive metadata store. This Hive metadata store also integrates with things like Amazon Athena, with things like with EMR, Elastic MapReduce, as well as Redshift Spectrum, which we're going to demonstrate here today. But also there's the job authoring and job execution. And this is really great if you want to do things like populate your instance storage on your data warehouse. So Redshift Spectrum could leverage the data catalog to be able to query the data that lives on S3, but there's still times where you may want to load your data onto the cluster. And that's where job authoring and job execution come into play. The AWS Glue data catalog, here's a visual representation of it. And it really allows you to have various metadata forms from various data sources. Some of this metadata might be Redshift, other pieces of the metadata might come from S3. And we're going to demonstrate exactly that next, having a data set in Redshift and then being able to query existing data in S3 through the data catalog. The data catalog leverages what's called classifiers. And classifiers are used to be able to identify various data formats, as well as the data types within that data format. So there's a lot of built-in classifiers for things like Amazon RDS and Amazon Redshift, but also for your data that lives in Amazon S3. What it allows you to do is point your data to any particular data set And the classifiers that are built in will automatically identify things like, is this data Parquet? Is it JSON? Is it delimited? And after it identifies that, it also identifies the various data types. So databases oftentimes have a data type for each variable or each field, but things like a CSV won't have a data type. But the classifiers automatically look at the data and will identify types such as this is a small int, this is a string, this is a double, those sorts of data types. And the way this works is when you're populating your Glue data catalog, you could point it to a wide number of data sources. And those could all become essentially data sources for your Glue ETL. After you've defined your data sources and you want to perform ETL, it's time to write the actual process or the job. And there's really three different methods of being able to do that. The first is being able to have AWS Glue generate Python code for you and have it run the PySpark for you. And we're going to demonstrate this here very shortly to be able to pick a data source in S3, pick a data source in Redshift, and generate the ETL code for me. But there's a few other ways to also talk about that you could create your jobs. The first is being able to iteratively develop it. So if you want to connect in a Zeppelin notebook or another style notebook and develop your code, you could do it that way. You could also plug in various IDEs into the Glue developer endpoints and develop your ETL logic that way. The last method worth discussing is you could also bring your existing code into AWS Glue. So if you already have some PySpark code that you want to be able to execute and bring in, you can simply point it to it in S3 when you're creating your job, and you could use that script instead of generating its own. This is a depiction of what it looks like to do that mapping. So over on the left-hand side, you'll see an image showing the source and destinations and being able to apply various mappings to that. After you generate your PySpark code, it's very easy to create your own transformations, add your own Python code, really adjust the ETL however you like. One common adjustment or one common use case is being able to take semi-structured data, this could be in a JSON document for example, and want to populate a relational schema such as a data warehouse. AWS Glue has a really powerful transform called Relationalize that does this, which allows you to create a set of tables, a set of dynamic frames that could be used to populate various tables within your ER style schema definition. It does this very quickly and is able to very easily store from JSON to various relational forms like your data warehouse. So tying these things together here, what we talked about is being able to have your ETL be populated through serverless. So with Glue, we've talked about being able to write your ETL script, being able to launch this script and execute it without spinning up a single server yourself. And this is a depiction of what that looks like. So the Glue ETL runs. It will run within your own VPC. We'll step through what that setup looks like here in a moment. And you're able to read your data from various data sources. It could be a relational database, it could be S3, and do things like populate your Redshift data warehouse. All of the different logs and notifications are actually pushed to CloudWatch logs as well. That gives you visibility in terms of how those ETLs are executing. So even though it's serverless and you don't have to worry about spinning up servers, you still have visibility in terms of how the application or how the ETL is executing. The last service we're going to talk about, and then we're going to dive into the demonstration, is Amazon QuickSight. Amazon QuickSight really allows you to bring business analytics into the cloud. It's built for the cloud and allows you to very easily visualize and explore your data. There's some key concepts or key aspects to QuickSight. The first is data sources. There's a very wide number of data sources built into QuickSight. You can very easily connect it to Redshift, Enterprise Data Warehouse. You can connect it into Athena, which is our ad hoc query service. You can plug it into RDS or flat files within S3. But we have a lot of external connections as well as, for example, you connect into Salesforce or Snowflake or Teradata. But these data sources allow you to be able to capture your data. Once you have your data, you could create various data sets. Data sets might be a combination of various tables from your database or data warehouses. It might be a filtered data set where you want to reduce the data that's put into a data set. And it might also include things like a calculated field, which might be derived fields from other columns that your business analyst could analyze. Analyses really allows you to build a set of visualizations off of a set of data sets. So one analysis might have a large number of visualizations on it, and each of those visualizations might be populated from different data sets from different data sources. And then from there, you could create dashboards, which are read-only views of the data, and then storyboards, which allow you to capture a series of steps of visualizations to capture the process of analysis or a process of driving a business question. All this, of course, could be integrated with things like single sign-on, Active Directory, or local user definitions, defining your users. There's very nice deep integration with AWS services such as Redshift, RDS, Athena, and S3. But you don't have to necessarily leverage those services if you don't today. They're very, very great services. They're very, very powerful. But if you already have your data in a MySQL, Postgres, or various databases, you could bring those data sources in as well. The other aspect of QuickSight is SPICE. It really stands for Super Fast Parallel In-Memory Optimized Calculation Engine. And what it is a highly available, secure in-memory engine that allows you to cache your data sets in memory. That way you could very quickly do your analysis. If you have hundreds or thousands of users using QuickSight, they could all hit the same SPICE in-memory data set and be able to return queries very, very rapidly. There's no hardware to manage, no software to manage. It's all handled under the covers through the QuickSight engine. So what we're really going to be doing, and we're going to demo after this next slide here, is we're going to be showing how you can start with your data warehouse, Amazon Redshift. From there, we're going to show you how you could use the crawlers to discover your data sets using the AWS Glue data catalog. From there, we're going to show you how you could write a serverless ETL to be able to take existing data in S3 and populate that data warehouse without spinning up a single server. After we do that, we're going to show how you could expand and not necessarily load all of your data sets into Redshift, but leverage things like Redshift Spectrum integrated with the Glue data catalog to be able to query both the data sets that's on the instance storage as well as data sets that might be in Redshift Spectrum. And then lastly, we're going to visualize that data in Amazon QuickSight. So let's dive into that. What we're going to start off doing is we're going to go ahead and connect to that data warehouse. We're going to go ahead and JDBC into it and show some of the simple queries that you could do, along with some of the more complicated queries. So we're going to start off by just pulling the top 50 events, or the first 50 events in the data set. And what you can see is various categories such as concert, pop, musical, shows, opera shows, that sort of information already in the data warehouse. What if we want to start populating the data catalog now? What if we want to have a data catalog that captures this information, but also has our information of your data lake on S3? What we could do is we could leverage the AWS Glue service in order to do that, the Glue data catalog. When we look at the Glue data catalog, I'm starting off here without any tables defined. What we're going to do is we're going to start off by crawling a Redshift data warehouse, essentially the data warehouse we were just looking at. I could go in here and I could run this crawler. And what this is doing is it's crawling that data warehouse for me and identifying all the different tables within that data warehouse. If we go ahead and look at the settings here, you'll notice this is a JDBC endpoint that we're crawling. And it's using this Redshift connection, which we're going to look at next. You could also specify various include and exclude paths if you want to include various tables during your crawling or exclude various paths such as system tables, that sort of thing. If we take a look at the actual connection itself, the connection is connecting to the data warehouse through an endpoint, but the connection is happening through a private subnet here. So this allows the crawlers to run in your protected space, in your isolated network space, and run in that private IP range and have this security group applied on top of it. You could very easily connect to Redshift like we are right now, but you could also connect to Amazon RDS. You connect to your own databases running on EC2 this way. If we go ahead and go back to the crawlers here, what we could also do is we could start crawling some other data sources. We're going to crawl our data lake as well. Our data lake, or some files that we have on an S3, and have it populate the data warehouse or the data catalog for us based on what it finds. So this is using the built-in classifiers to be able to identify what objects are out there and classify them in things like CSV, JSON, Parquet formats. So what I'm going to do is I'm going to go ahead and select that crawler and hit run crawler for there. What we could do now is, as that's crawling, we could go back to this data catalog. And what we're going to notice right away is we notice some of the crawlers, what we found is the Redshift data warehouse crawling. So we see these various tables here listed, and you see things like venue, event, date, category. And these are all classified by Redshift because this was found through the Redshift crawler. So these are all tables in our data warehouse. If we give it a minute and we refresh again, you'll notice a lot more tables showed up now. This was the second crawler finishing. So now we actually have our tables out of their data lake, out of our objects in S3, but we also have our objects or our tables that are actually in the data warehouse itself. What we could do next is we could start creating our ETLs. Let's say that we have some additional event data out of this S3 location that we want to populate our data warehouse with. Let's go ahead and step through and create an ETL to do that. What we could do is we could go ahead and hit add new job and specify a job here. All the jobs run with a specific IAM role that gives you ability to be able to have least privilege access. And then you can set some various settings here. Let's go ahead and select the events data out of S3 as our source and say we want to populate our data warehouse with that data. And with a few simple clicks, what we've done is we've go ahead and we said we want to take the data out of this database and populate the data warehouse with that data. What we could do next is we could hit next and finish. And with a few easy clicks, we have this script that has already been generated for me. Now I could go ahead and run this and populate my data warehouse out of my data that's living on S3. I could also do things like if I have JSON data, start calling that relationalize function to be able to populate multiple tables rather than just populate one table with the data set. So in this example, we're going from one table in a CSV form into one table in Redshift, but you could very easily go from multiple tables in a JSON format into multiple tables into Redshift. Let's go ahead and go back and look at the data catalog again. One of the things we'll notice out of this data set is Redshift has a whole bunch of the data already, but we don't have sales information in Redshift. So we notice the sales information, the CSV data on S3, that isn't actually in our data warehouse yet. If we take a look at this data though, we see a lot of things like seller ID, buyer ID, and event ID. These are all IDs that are referencing data that's already in our data warehouse. So wouldn't it be really nice if we could start querying this data using Redshift Spectrum? And we're going to do exactly that. So next what we're going to do is we're going to go ahead and join this data set with existing data that we have in our data warehouse. To do that, we're going to go ahead and bring up the SQL window. And we're going to start querying this data set. We're going to start off by querying based on the date. This is joining the data that is in S3, the sales data that we were just looking at, with data that is in a dimensional table on Redshift. And when we go ahead and query this, what we'll notice is within a couple seconds it returned very, very quickly. And this is the total number of quantities sold on a particular day for the venues. Let's say we want to start doing a little bit more advanced queries and pull the top 10 sale events in the next query. So this is taking a look at the event data, the event ID, but it's also looking at the sale data to be able to pull out that data. And these are the top 10 here, pulling back the event ID. Next, if we want to know the top 20 buyers, who are the top 20 people going to these various venues, we can start joining that data that's living in S3 with additional dimensional data sets. In this one, we're actually joining it with the users table, or the user dimension. And what we'll notice is here's now we see the top 20 users and how much quantity each user has purchased. In the next two queries, we're going to do a little bit more advanced queries. We're actually going to do a 99th percentile. And one of the things you'll notice as we're doing all these queries is me as a user querying this data set, I just need to issue the Postgres, the Redshift compliant queries, and the leader node is automatically delegating the work down to the Spectrum nodes where it needs to, and then joining the data sets with the data that's on the instance storage and then bubbling the results back up. So very, very seamless to be able to bring that data set that's on S3 and combine it with your data set that's already on your data warehouse. And the last query that we're going to do, and then we're going to show some business intelligence, is we're going to join this data with some category data. So in addition to the event name, we want to pull back what is the category of that event. So we just bring in another dimension table here that's actually on the cluster, join it with the event table on the cluster, as well as the data that's on S3, the sales data. And when we do this query, it's going to return back all the information that we asked for, the category of the event name, along with the price for that event, or the total price, the total revenue of that event. So very, very powerful to be able to start bringing this data in. What if I want to start visualizing this data using a BI tool though? I could very easily do that using QuickSight. So the first thing I'm going to do is I'm going to switch the regions of QuickSight to be in Oregon because that's where my data warehouse is running. But as soon as I do that, what I could do is I could start building a data set. So we're going to go into Manage Data Set and say New Data Set. And this allows me to do things like auto-discover my Redshift cluster that's running in that region or my RDS instances. But it also lets you connect to your MySQL databases, your Postgres, your Presto, various data sources where you might have data, along with things like Salesforce and Teradata and Snowflake. So very easy to bring in various data sets into QuickSight. We're going to focus on Redshift, and we're going to create a new data set. And one of the things you'll notice here is I could very easily bring in the data from Redshift Spectrum. So this is actually the data that Glue discovered and Redshift Spectrum is using, and I could bring in that sales data. But I could also bring in the data that's actually on the instance on the data warehouse itself, such as event. And let's go ahead and select Edit and Preview. What this allows us to do is do things like calculate new fields. I could create calculated fields based on the event time. I could calculate average distances, various formulas to create new fields in the data. I could also very easily add new filters on the data set to be able to apply it on top of the data being used for visualizations. But let's join this data set together. So this events table is actually on the cluster itself. But let's take a Redshift Spectrum data set and say the sales data, and say I want to join this data set together. And very easily I could join on the event ID, and then select the event ID out of the sales table and specify what type of join I want to perform there. The other thing that I could do is, let's say I have a very custom query. Let's say I want to use the same query that I used previously using SQL Workbench. And I want to specify a query rather than dragging and dropping my join criteria here. I could do that very easily by selecting the query name. I could give it a name called webinar here, specify a query, and hit finish. And what will happen is it's going to create a new data set based on that custom query. So very easy to create advanced queries across your data sets, build this data set however you'd like, and then start to visualize it. So let's go ahead and hit save and visualize next. Here what we could do is we could start visualizing this data. And remember, this is part of the data is actually on the warehouse itself. Part of it's actually living in S3 as we're querying this data set. So what I could do is I could go ahead and look at the category name and the total price and add that as one visualization. And what you'll notice is, very easily, all I did is I selected a couple categories and automatically it identified the way it wanted to plot that data. Down here in the visualization type, I can select a different way of visualizing the table. What if I want to see this as a pie chart? I could select that and I'll use a pie chart instead. I could go in here and I could create a new visual. And put this next to the one that we just created. So it's very easy to drag and drop these windows and these add different visualizations on top of here. So in this example, if we wanted to look at the category group and add another visual underneath it, we could do that. And with a few simple clicks here, now we can look at the event name. We've built a dashboard using the data that's partially in the data warehouse, the dimensional data, but we've also joined that with data that's schema on read through the data catalog using the Redshift Spectrum, and built this visualization using that joined data set. So what we've done is throughout this, we've really augmented our data warehouse, our enterprise data warehouse using Amazon Redshift with serverless technologies such as Amazon AWS Glue, using the data catalog and the ETL, and using QuickSight to be able to visualize the data, and using Redshift Spectrum to be able to query that data at rest using the data catalog. So from there, we're going to step back out of the presentation. So what we just demonstrated was essentially this flow. What we started with was the Amazon Redshift data warehouse. We're able to show how you could use Glue to run serverless ETL if you'd like, but also you could use the AWS Glue data catalog and leverage Amazon Redshift Spectrum to query your data. When you do that, your data stays on S3, is using the Glue data catalog to describe that data, and Spectrum is doing the querying against that data and bringing that together onto your Redshift cluster to be able to drive insights. And then from there, you're able to visualize those results using QuickSight and build various representations of that data. So I want to thank you for your time. We'll stick around for a few moments after this to be able to continue answering questions on the Q&A panel. And appreciate everyone taking the time to learn about how various serverless analytics and services could really complement that data warehousing workload. Thank you.